I've stated emphatically that along a transmission line, a transmission line with the source at one end and the load at the other, that the incident power will be greater than or equal than the power delivered by the source. And again, this is important. It's oftentimes in students' minds feel like the incident power should be equal to the delivered power, but again, it's greater than or equal. Now, the fact that we have greater than or equal means there are some cases where, in fact, the incident power could be equal to the delivered power. And so let's think about what that case might be. If we look at, again, the fundamental equation of conservation of energy of a transmission line that's connected to both the source and a load, we look at this and we see that in order for the power delivered by the source to be equal to the power associated with the incident wave, the only way that could be true is if the reflected power were equal to zero. So clearly, if the reflected power equal to zero, then the delivered power would be equal to the incident power, which of course then would be equal to the net power flow along the transmission line. And so this is the case under which the incident power, the one case, the only case under which the incident power and the delivered power of the source are equal to each other. We might ask ourselves then, under what condition is the reflected power equal to zero? Certainly, if we look at the relationship between the reflected power and the incident power, we see that the reflected power will be equal to zero if this magnitude of the reflection coefficient, load reflection coefficient, I should say, is equal to zero. For if the magnitude of the load reflection coefficient is equal to zero, then of course clearly the load reflection coefficient itself is equal to zero. So we can make this statement that the delivered power and the incident power are equal to each other under the condition that gamma L is equal to zero. So we could then further extend this and say, under what condition is gamma L equal to zero? And hopefully you know what condition that is. Gamma L, the load reflection coefficient, is going to be equal to zero clearly when ZL is numerically equal to the characteristic impedance of the transmission line, Z0. In other words, gamma L is going to be zero when the load is a, quote, matched load, when it's numerically equal to Z0. And of course, this corresponds to a point on the complex gamma plane, which is at the origin of that complex gamma plane. So since I have the opportunity to emphasize this one more time, I will. If we have a, quote, matched load, a load is numerically equal to Z0, real part of Z0, an imaginary part of zero. In other words, a load that is purely real, resistive, with a resistance value numerically equal to Z0, we have this matched load. And what do we know happens in that condition? Once again, I emphasize it has nothing to do with a conjugate match. We cannot conclude we have a conjugate match, that the available power of our source is being delivered to the load. All we can say is if that our load is numerically equal to Z0, it is, in quotes, matched to the characteristic impedance of the transmission line. Under that condition, we know, as we just found, that the reflected power is going to be equal to zero. Of course, we also know that the input impedance of this terminated transmission line must have a value that is also numerically equal to Z0. This comes from the fact that the line impedance function, if it is terminated in a matched load, the line impedance function everywhere on our transmission line is the same value. It's equal to Z0, which means Zn is equal to Z0, of course. And the most important thing, and I want to emphasize this is true regardless of transmission line length. Again, if we have a matched load, it means the reflected power is equal to zero, and the input impedance is numerically equal to the characteristic impedance Z0, and that's true regardless of the length of the transmission line. Those two facts and those two facts alone are the only things we can conclude when we have a, quote, matched load.